Hi, I am Dr. T.V. Lakshmi, working as an associate professor in the Department of ECE in SRKR Engineering College. In this lecture, I would like to discuss the 4-bit universal shift register. This is the diagram of the universal 4-bit universal shift register. It is a 4-bit universal shift register, so it consists of 4 D flip-flops and 4 is to 1 multiplexers. It can be extended to n-bit universal shift register by adding the few more. That means if it is a 5-bit shift register, 5-bit universal shift register, there are 5 D flip-flops and 5 4 is to 1 multiplexers. Similarly, we can extend this to n-bit universal shift register by connecting a n D flip-flops and n 4 is to 1 multiplexers. Why it is called as universal shift register? Because it can perform the many operations, many shift register operations. Those are shift left register, or it can be operate as the right shift register, or it can operate serial in serial out shift register, or parallel in parallel out shift registers. So by using this circuit we can perform these operations, that is left shift register, right shift register, parallel in parallel out shift register, serial in serial out shift register. That's why it is called as universal shift register. Let us see the working of this universal shift register and connections of the this circuit to perform these operations. Those are, it can operate these modes, and you have to select these selection lines of the multiplexers as 00, 01, 10, 11 to get the no change, shift right, shift left, parallel load operations. Suppose if you take this 00 operation, there is no change, it acts as a memory element. 00, to get this operation, it has to connect that outputs of the each flip-flop has to connect to the 0th input of the this multiplexer. That is, we can say that is the D naught. If you connect this D naught from the output of the that particular flip-flop, if it is connected to the 0th input of the that particular multiplexer, then if we select the 00, this output is the D naught. That is, D naught means that is the output of the this flip-flop. So this output of the flip-flop is connected to the 0, and this output is the 0th input, so it gives the that output the same as the previous output. Similarly for all the flip-flops, to get this operation we connect this all the selecting lines, that is S1 of the each flip-flop has to connect together. Similarly S0 of the each multiplexer has to connect together. That is, when it selects the 00, it selects the 0th, that is the D naught of the that particular multiplexer that appears at the output. So for the D naught, it has to connect to the output of the that particular flip flop to the D naught of the that multiplexer. Here this D naught is connected to the this output. So when it is the 00, this output is the D naught, so it gives the D naught to the input of this D flip flop, then that is the output. That is same as the previous output. That is the 00 or no change state. Next, let us see the next connection, that is 01. 01, that is the shift right. That is the shifting the input data from left flip flop to the right flip flop. That is the shift right register. When the selecting lines are 01, when these selecting lines are 01, it selects this D1 input. That is, so it is connected to the serial input for the shift right operation. Here this serial input, it is connected to the first flip flop, and this output of the this flip flop is connected to the D1 input of the next multiplexer. Then when these inputs are selecting inputs are 0 1, it selects this data line, the data input that is connected to the output. Then it takes this input from the 4:1 multiplexer, that is the D1 input, data input, first input of the this multiplexer, and it gives that output, and it is connected to the data 1 input line of the next multiplexer. Similarly for this flip flop, and it is connected to the this one input of the that multiplexer. Then if the inputs are 0, selecting inputs are 0 1, this it takes this data 1 input, it selects this data input, and it is connected to the output. That is it is shifting this input data from left to right. That is the right shift register. Next, let us see this shift left operation. That is for 1 0. If the selecting inputs are 1 0, all the selecting lines of the multiplexers are the 1 0. Here, when it selects the 1 0, it takes this third input on that D2. If it then here serial input for the shift left operation. Here the external input is connected to the D2 of the this last flip flop. Then when the selecting inputs are 1 0, it selects this inputs. The output of the multiplexer is the input of the this D2, that it takes that it gives the output from the this second input, that is the D2 input, that is the external input, that it takes the input, and here this output is the output of this flip flop is connected to the second input, that is the D2 input of the this multiplexer. That is here the output of the this flip flop is connected to the D2 input, means that is the third input of the this 4:1 multiplexer. When the selecting inputs are 1 0, it selects this third input or D2, and it gives the output. So this output, this input appears here, and it takes that is the D input, and that is the output of this flip flop, and it is connected to the this third input of the next multiplexer. And when it is a 1 0, it is the input to the this flip flop, and this output is connected to the input of this multiplexer. Due to this selecting inputs 1 0, this output, this input data input appears at the D, and this is the output. This is the output for the left shift register output. That is, it is shifting the input from the right side to the left side. That is the shift left operation. Next, let us see this parallel load, means parallel in parallel out. It also can perform that parallel in parallel out shift register. That is, we can give the inputs parallelly when the selecting inputs are 1 1. When the selecting inputs of these multiplex are 1 1, it selects the fourth input of that data inputs. That is, when it is a 1 1, it selects this D3 or fourth inputs. So if you connect that out inputs, external inputs to this D3, then it selects this fourth inputs. That is, here that output appears this fourth input, that is due to this selecting lines inputs, that is 1 1. Here that output is this I3 for this flip flop A3, that is the output is the A3 equal to, it is I3, and it is the I2, because here I2 is connected to the fourth input of this multiplexer. So it is I2, and it is the I1, and it is the I0. Here when the selecting inputs are 1 1, it acts as a parallel in, parallel out shift register. That is the universal shift register. We can observe that these selecting lines 0 0, there is no change, and we are using the 0 0 for the no change state. We are using the 0 0 selecting inputs, and 0 1, this is shifting 0 to 1, that is the right shift register, and 0 1, it is these inputs are using as the shift left operation, and these are the parallel in, parallel out mode. Means that is, we can remember these connections very easily by these selecting inputs. It means 0 0 అంటే there is no change. సో ఇక్కడ మనం 0 0 అనే దాన్ని నో చేంజ్ మోడ్లో యూజ్ చేస్తున్నాం. అలాగే 0 1, ఇక్కడ మనం ఒకసారి క్లియర్గా అబ్జర్వ్ చేస్తే, అంటే ఇక్కడ 0 డేటా ఇలా రైట్కి షిఫ్ట్ అవుతున్నట్టుంది. దాన్ని 0 1ని మనం రైట్ షిఫ్ట్ రిజిస్టర్గా యూజ్ చేస్తున్నాం 0 1 సెలెక్టింగ్ లైన్స్కి. అంటే ఇక్కడ 0 1 ఇచ్చినప్పుడు దాన్ని రైట్ షిఫ్ట్ రిజిస్టర్గా యూజ్ చేస్తున్నాం. సో మనం దాన్ని అలా కూడా ఈజీగా గుర్తుపెట్టుకోవచ్చు. 0 1 అంటే రైట్ షిఫ్ట్ రిజిస్టర్ దట్ సెలెక్ట్స్ ద రైట్, లెఫ్ట్ నుంచి రైట్కి షిఫ్ట్ అవుతుంది. సో మనకి ఇక్కడ 1 ఇన్పుట్ దగ్గర ఇక్కడ ఇన్పుట్ ఇస్తున్నాం. అలాగే ప్రతి ఒక్క 1 ఇన్పుట్కి D1 ఇన్పుట్కి అవుట్పుట్ నుంచి దీనికి ఇస్తున్నాం. అంటే ఇక్కడ రైట్ షిఫ్ట్కి ఇచ్చేసినప్పుడు, అలాగే షిఫ్ట్ లెఫ్ట్ షిఫ్ట్ రిజిస్టర్గా ఇచ్చేసినప్పుడు ఇక్కడ నుంచి 0 ఇలా షిఫ్ట్ అవుతుంది అని మనం జస్ట్ అలా గుర్తుపెట్టుకుంటే వీ కెన్ రిమెంబర్ ఆల్ దీస్ కనెక్షన్స్. ఇఫ్ యూ సీ అట్ ఏ గ్లాన్స్, it is a very complex circuit. If you understand properly, it will be very easy to remember, and it can be designed very easily. Wish you best of luck. Thank you.